Hi, hope all of you doing well. Today I am going to discuss new exercise 1.2 of real numbers. So before start the exercise, we will discuss some few basic points, then we will go directly to that exercise. Those numbers which I can write in the form of P by Q, and Q is not equal to 0. Here P and Q are Q are integers. P and Q are integers. Example, take an example, 1 by 4, 5 by 7 or minus 3 by 8, like this, etc. So these are called rational numbers. And we see some properties of rational numbers. Sum of rational numbers. We'll see. Example, 1 by 4. I am taking 1 by 4 plus 2 by 3. These two are rational numbers. If I add, 12 is LCM, and 3 plus 8 is equal to 11 by 12. So 11 by 12 is a rational number. You can say that sum of rational numbers is a rational number. One more property. Difference of rational numbers. What happens when we subtract the difference of rational numbers? I am taking one example. A number is a 1 by 4 minus 2 by 5. Example. Now we know that LCM is 20. 5 minus 8 equal to 5 minus 8 equal to minus 3 by 20. Here minus 3 by 20 is a rational number. That means you can say that difference of rational number is a rational number. Why? Prime numbers are the numbers, they have only two factors, 1 and the number itself. So those numbers called a prime numbers. Example, I am taking 3. Factors of 3. 3 are, what are those? 1, 3. Suppose I am taking the 5. Factors of 5 are 1, 5. The factors of 11 are 1, 11. See here, if you observe these numbers 3, 5 and 11, so they have the only two factors, 1 and the number itself. So these numbers are called a prime numbers. So one more point, what are the co-primes? What is meant by co-prime? Co-prime numbers. Co-prime numbers are those numbers which, if I take in two numbers, their HCF is 1, only 1. So then the number is called a co-primes. Example, 15 and 28. I am taking example. So I am taking 15, write factors of 15. Factors of 15 are 1, 3, 5 and 15. They are the factors of 15. Factors of 28 are 1, 2, 4, 14, 7, 28. These are the factors of 28. If you see that What is the HCF of 15 and 28 is, what the HCF of 28 is, what that? Here you can see that only 1 is the common, highest factor. Highest common factor is only 1. Then we can say that 15 and 28 are co-prime numbers. So understand, Anna? So what is mean by co-primes? Co-primes means that if take two numbers, in the two numbers, their HCF, highest common factor, only 1, then the numbers are called co-primes. If any number, suppose I am taking one more example. Yeah, one more example. 15 and 10. 15, example 15, comma 10. 15's factors of 15 are, just now we discussed, 1, 3, 5, 15. Now factors of 10 are 1, 2, 5, 10. HCF of 15 and 10. So here, what is the highest common factor? Highest common factor is 5. Yeah, is 5. Now, can we say 15 and 10 are co-primes? No, because for this HCF is more than 1. So that's why. So it is. So the HCF of is not equal to 1. So 5 is not equal to 1. Therefore, you can say that 15 and 10 are not a co-primes. This is the definition of the. So this is the meaning of the co-primes. Now we are going to irrational numbers. Irrational numbers. You know that irrational numbers are those numbers which we cannot write in the form of P by Q. So which numbers we cannot write in the form of not P by Q, and Q is not equal to 0. So then those numbers are called irrational numbers. So example, root 2, root 3, root 5, pi, and some decimals. The decimals are not, so the non-terminating and non-repeating decimal expansion. So 0.10, 110, 00, 111, 000, 1, so on. Like this is going on. So these are also called irrational numbers. Theorem 1.2. Let P be a prime number if P divides A squared, then P divides A, where A is a positive integer. And the proof, let the prime factorization of A be as follows. Prime factors of A. A is equal to P1, P2, P3 and so on Pn, where P1, P2 and Pn are primes, not necessarily distinct. Just before also I explained, suppose prime factors of 12. Prime factors of 12 are, what are those? 2 into 3. So here, prime factors here is saying that P1, P2 and P3 not necessarily distinct. Means, see here, not so all the prime factors are not the different ones. So here this is repeated on 2 is a some factor prime factors are repeating. So that's why I say that it's not that necessarily that P1, P2, P3 all are so distinct. So you know the meaning of distinct. Okay. Therefore, a square equal to p1 into p2 into p3 into p4 and so on into pn. So a square, once again I am writing that a into a. So p1 into p2 into p3 into and so on into pn. So this will be become as a p1 square, p2 square, p3 square and pn square. So now we are given that p divides a square. Yes or no? It's given that p divides a square. P divides a square means what? P is the one of the prime factor of 12 square. Yeah, a square, sorry. So one of the prime factor of a square. Therefore, from the fundamental theorem of arithmetic, it follows that p is one of the prime factor of a square. However, using the uniqueness part of the fundamental theorem of arithmetic, we realize that the only prime factor of a square are p1, p2 and pn. So p divides p1, p2 and pn. You know that, So when p divides a square means p is the one of the factor, prime factor. That's why p divides a square. Since a also, a is equal to what? What are the prime factors of a? p1, p2 into p3 into p4 into pn. So in this also same prime factors are repeated in a also. That means p also one of the prime factor of a. That's why p divides a. Prove that root 5 is a irrational number. Now how will you prove? Let us assume p is a rational number. Let assume root 5 is a rational number. Is a rational number. That means I can write root 5 is equal to p by q, because root 5 is a rational number and q is not equal to 0. Here p and q are integers, p and q are integers and one more point, p and q are co-primes. So what do you mean by co-prime? Co-prime means they have their common factor. This highest common factor is only 1. So here p and q, they don't have any common factor other than 1. That's the meaning. Not. So I can write this one is like this. Q root 5 is equal to p. Squaring on both sides, q root 5 is equal to p square. This will be 5 q square is equal to p square. Now by this, what we can say, 5 divides p square. 5 divides p square. So therefore, we can say that 5 divides p also. So you remember one thing, that means 5 is a factor of p. 5 is a factor of p. That means p is a multiple of 5. So I can write p is equal to 5k, because p is a multiple of 5. So p is calculated as p is equal to 5k. Here k is a positive integer. Is a positive integer. k is here, k is any positive integer. Okay. Now, if p is equal to 5k, substitute in the equation here. We got equation 5q square equal to p square, then it becomes a 5q square is equal to 5k whole square. Five q square is equal to 25k square. 5q square, 5 q square is equal to 25 k square. Here 5 1 ja, 5 5 ja. You can write as a q square is equal to 5k square. Q square equal to 5k square. So here also by this you can say that 5 divides q square. 5 divides q square. That means we can say that, or we can say 5 divides q also. 5 divides q also. Means what? 5 is a factor of q. So here what we observe, 5 is a factor of p and 5 is a factor of q here. But we know that p and q are p comma q are co-primes. P and q are co-primes, but here co-primes means they have only one as a factor, but here 5 is a factor of p and q. It is a contradiction. It is a contradiction. It is contradiction. Why? Because why it's contradiction? Why? Because our assumption is wrong. So because our assumption is wrong. Therefore, we can say that root 5 is an irrational number. Hence proof. This is the way we can prove that root 5 is an irrational number. Now, next question. Question number 2. Prove that 3 plus 2 root 5 is a rational number. Okay, similarly, let us assume three plus 2 root 5 is a rational number. Is a rational number. Okay. Then we can write 3 plus 2 root 5 is equal to p by q. Here q is not equal to 0. You can say that here p and q are integers, p comma q are integers. So now I can write this one. 3 plus 2 root 5 is equal to p by q minus 3. I can write. This one 2 root 5 is equal to, I can write as a p minus 3 q by q. So I am taking to this side, transposing to LHS to RHS, root 5 is equal to P minus 3q by 2q. Yeah. If you observe here in this one, in RHS side, if you observe the RHS side, here P, Q are integers, 3 also integer and 2 also integer. That means, so this RHS is a rational number. We can say that here P comma Q comma 3 and 2 are integers. Therefore, you can say that, therefore, you can say that P minus 3q by 2q is a rational number. Is a rational number. Okay. If this is a rational number, means RHS is LHS equal to RHS means, so if this part is a rational number, so P minus 3q by 2q is a rational number, that means root 5 also a rational number. So, by this we can say that root 5 also a rational number. So root 5 also a rational number. But we know that root 5 is an irrational number. Is an irrational number. So it is a contradiction. So root 5, here we say that root 5 is a rational number, but we know that root 5 is a rational number. It is a contradiction. Why? It is a contradiction arises due to our assumption is contradiction arise why? Because our assumption is plus 2 root 5, 3 plus 2 root 5. Therefore, we can say that our assumption is wrong. Therefore, our assumption is wrong. You can say that 3 plus 2 root 5 is an irrational number. And it's proved. This is the way we can prove. So one more question. Third question. 3 point. Third question, first problem. Prove that 1 by 2 is a rational number. Let assume 1 by root 2 is a rational number. So therefore, you can say that I can write like this: 1 by root 2 is equal to P by Q. Here q is not equal to 0 and p and q are p comma q are integers. Integers. So I can write this one, cross multiply, q is equal to p root 2. Yeah, q by p is equal to root 2. If I rearrange this one, I can write as a root 2 is equal to q by p. You know that q by p is a rational number. So q by p, you know that q is a integer and p is integer. So q by p is a rational number. P is a rational number. So if p by q is a rational number, then root 2 also rational number. But we know that root 2 is a irrational number. But we know that root 2 is a irrational number. Irrational number. Why it is happen? Because so it is contradiction. Why? Because our observation is therefore it is contradiction. It is contradiction. Because due to, so we consider it as a contradiction because our assumption is wrong. We can say therefore root 2 1 by root 2 is a irrational number. Hence prove. Next question. Prove that 7 root 5 is irrational. It is similar. So 7 root 5. Let us assume 7 root 5 is a rational number. Is a rational. Then I can write 7 root 5. 7 root 5 is equal to p by q. And q is not equal to 0. P and q are integers. P comma q are integers. Now I can write this one is a root 5 is equal to p by 7 root 5. 7 q. Root 5 equal to p by 7 q. Now here you know that p, q, 7 are integers. Therefore you can say that here p comma q comma 7 are integers. Therefore, we can say that P by 7 cube, P by 7 cube is a rational number. Then, so therefore we can say that root 5 also, therefore root 5 also rational number. But we know that root 5 is a irrational number. We know that root 5 is a irrational number. But we know that root 5 is a irrational number. Irrational so why this happened? Because our assumption is wrong. It is the contradiction. This contradiction arises. This contradiction arises. We assumed that 7 root 5 is a rational number. Therefore, our assumption is wrong. Therefore, you can say that therefore our assumption is wrong. You can say that 7 root 5 is a irrational number. Hence proved. Next question. Prove that 6 plus root 2 is a irrational number. Let assume, here also same. Let assume 6 plus root 2 is a rational number. Is a rational number. What we can say? Then I can write 6 plus root 2 is equal to p by q. Here q is not equal to 0. P comma q are integers. Yeah. So now I can write root 2 is equal to p by q. You know that 6 is transports to RHS becomes a minus 6. Yeah. Now here, see p by q is a rational number, 6 also rational number. Here, difference of rational number is a rational number. So we can say that p by q minus 6 is a rational number. We know that P by Q and 6 are rational numbers. Difference of rational numbers is a rational number. Difference of rational number is a rational number. Therefore, you can say that. Therefore, you can say that P by Q minus 6 is a rational number. Therefore, you can say the root 2 also rational number. Root 2 also rational number. According to this, because LHS equal to RHS, RHS equal to LHS, if this is this part, so RHS part, this is RHS. This RHS is rational number, means LHS is also rational number. But we know that root 2 is a irrational number. But we know that root 2 is a irrational number. So this is a contradiction. Why? So it is a contradiction arises because our assumption, we assume that it is contradiction so why? Because so it is contradiction. That's why you can why it's contradiction. Why? Because our assumption is wrong. Our assumption is wrong. Therefore, we can say that 6 plus root 2. 6 plus root 2 is a irrational number. 6 plus root 2 is a irrational number. Hence proved. Thank you for watching this video. So please like, share and subscribe. Thank you.